When we did that experiment, did all the metals react with equal speed? No. No, okay. So what was the most reactive metal that we saw? Potassium, okay. And after potassium, what was the next most reactive? We should have the 5 metals here, right? So what was the next most reactive after potassium? Sodium.
What do you remember?
And followed by?
Lithium.
Lithium. Then calcium. And finally, didn't do much of anything, was magnesium. Now, this one here below is the reaction between sodium. So let me highlight sodium for you. Sodium is Na. And water. Okay, water being H2O. And this one is unbalanced right now. And what always happens with most of our group 1, group 2 metals is that they produce what we call a sodium hydroxide. Now, hydroxide, as you remember from your ions list, is OH. Okay? And we also get the production of hydrogen gas. So let's have a look, okay, down here at water plus metal produces metal hydroxide. So in all of these instances, my metal, if I highlight the first 3 that we can do together, is always the same. Let's switch it so that I've got water as blue. And then finally, I have a metal hydroxide. Now, hydroxide, again, is only for group 1 and 2. And finally, hydrogen gas, H2. So let's write the word equation for this first one out together. So magnesium, metal, plus water, water, produces magnesium, excellent, magnesium hydroxide, plus H2 is hydrogen what? Hydrogen gas. Yeah. Okay. And those are the bubbles that we saw forming when we added our metal to our water in our experiment. So those were bubbles of hydrogen gas. Question?
How do you know if does it always produce hydrogen gas?
Does it always produce hydrogen gas? Yes. Every single time. So what we're going to do now below this is we're going to write out a chemical equation and then we'll balance it. So magnesium as a metal, we just write the symbol for magnesium, which is Mg, plus water, which I hope we all know is H2O. I draw a arrow pointing towards the right, not an equal sign, but an arrow. And then I write magnesium hydroxide. Now here's the trick. Magnesium, in its ionic form, has a charge of what? 2 plus. Hydroxide has a charge of -1. So I actually need 2 lots, hence the 2 here, of hydroxide. Now the brackets mean everything inside the bracket. And OH is hydroxide. So 2 lots of hydroxide. The final thing is hydrogen gas, and hydrogen gas is just H2. Yeah, question? Why is there 2? Because hydrogen likes to hang out with a friend. Yeah. So when we're talking about this one here, I'm going to scroll over to the left and I'll quickly rewrite this one. So magnesium metal plus water produces magnesium hydroxide plus H2. Now, in a test, you will get access to a whiteboard, so you can do this, but let's do this one together. So what do we always put first? Is it the element? Is it oxygen? Is it hydrogen? What should we balance first? Element. So I'm going to start with magnesium. Do I then go oxygen or hydrogen next? Oxygen, hydrogen. It's just going to help us out with some trickier ones. As of right now, how many magnesiums do I have over on the reactant side? So I'll write reactants up here. How many magnesium do I have? 1. What about over on the product side? How many do I have? 1. So the 2 is only of hydroxide. I only have 1 magnesium. So when we have a look at oxygen now, okay, how many oxygens do I have on the reactant side? 1, so 1 in H2O. What about over on the product side? 2, because I have 2 lots of oxygen, so I'm going to write 2 here. And finally, hydrogen. How many hydrogens on the reactant side? How many hydrogens over on the product side? 2 in magnesium hydroxide and 2 in hydrogen gas. So I've got 4. So let's have a look now very quickly, okay, just in the interest of time. Do I need to do anything to magnesium to balance it? No. What about oxygen? Do I need to balance oxygen? Yeah, and so what do I need to do? Add a 2 in front of the H2O. So if I do that right now, then I have 2 oxygens on this side, so that's all good. So I've got a tick so far, a tick so far. The only thing that I now need to check is hydrogens, because when I've adjusted the number of H2O, I haven't just adjusted the number of oxygens, but I've also adjusted the number of hydrogens. So how many hydrogens do I now have on the right-hand side, or on the reactant side left? 4. Is that balanced? Yeah. But here's the trick with these ones. I need to go back to the start and double check everything off. So I'm actually going to erase these ticks just to make 100% certain. So let's have a look. Magnesium on the left, 1. Magnesium on the right, 1. Tick. Next, oxygen on the left, 2 lots of oxygen, 2 lots of oxygen on the right, tick. And final one for me is 4 lots of hydrogen on the left, 4 lots of hydrogen on the right, tick. So our final answer, our final balanced equation is that right there. So what I'm going to get you to do, again, just because we're a little bit short on time, I'm going to get you to have a go at the rest of these for me. Now, the only thing to note, everyone, is when we get to the final 2, so just be very careful of number 9 and number 10, instead of hydroxide, okay, it is producing an oxide. Only in those 2. Otherwise, every single one is a metal hydroxide. So let's give those a go. If you're stuck, let me know and I'll wander around and give you a hand.